All right, let's tackle a question that comes up all the time for serverless developers. How do you take that awesome type-safe TypeScript code you love writing and actually get it running up on AWS Lambda? Well, today we're going to break it all down. Let's get right into it.
So, if you're watching this, I'm willing to bet you're already a fan of TypeScript. You get it, right? The auto-completion, catching errors before they ever hit production, that feeling of safety it gives you, it just makes building solid applications so much better.
And of course, you want to pair that with the raw power of AWS Lambda. I mean, who wouldn't? You pay only for what you use, it scales to the moon and back, and you can forget about managing servers. But that's the big question, isn't it? How do you make these two amazing technologies play nicely together?
Okay, so here's the one big thing you have to understand right from the start. The Node.js environment on Lambda, it doesn't speak TypeScript, not natively anyway. This means we have to do this little magic trick called transpilation. It's pretty simple, really. We just convert our TypeScript code into regular old JavaScript that the Lambda runtime can actually understand and run.
Now, to make that happen, you're going to run into two main tools. First, there's Sbuild, which is famous for being ridiculously fast. I'm talking like blazing fast. Then there's TSC, which is the official compiler straight from the TypeScript team. But here's the really cool part. If you're using modern tools like the AWS Serverless Application Model, or SAM, or the Cloud Development Kit, the CDK, they often just use Sbuild under the hood for you, making the whole process totally seamless.
Okay, so we know we have to transpile our code. With that in our back pocket, let's get to the fun part, actually writing our function. First things first, to really get the benefit of TypeScript, you need types for the events your Lambda is going to handle. And for that, there is one package you absolutely have to know. @types/AWS Lambda. It's a lifesaver. It gives you all the pre-made type definitions for stuff like API gateway requests, S3 events, SQS messages, you name it. No more guessing what's in that event object.
So let's pull apart a typical handler file and see what makes it tick. You'll have your imports at the top, of course. Then, and this is a huge best practice, you'll initialize things like your AWS SDK clients outside of the main handler function. Why? Because Lambda can then reuse that connection for multiple calls, giving you a serious performance boost. Then, you'll have your type definitions, your core logic inside an async handler, and you'll pull in any configuration you need safely using environment variables.
Now, when you're writing that handler, you technically have a choice. There's the old school callback pattern, but honestly, let me make this easy for you. Just use async await. It's a no-brainer. Your code ends up looking clean and synchronous, error handling is a piece of cake with a simple try-catch, and you completely avoid that tangled mess we all know and fear as callback hell. Okay, our code is written, it's looking good. Now what? How do we actually get this thing from our laptop into the AWS cloud?
You've basically got two ways to package your code for delivery. The classic, most common way is a simple zip file. You just bundle up your compiled JavaScript and your dependencies. It's fast, it's simple, and it's perfect for most situations. The other option is a container image. This gives you a ton more control over the environment and is super useful if you have really large dependencies or need some custom runtimes.
And to actually push that package up to AWS, you've got a great toolkit to choose from. Frameworks like AWS SAM and the AWS CDK are fantastic because they automate pretty much everything for you. The transpiling, the packaging, the whole shebang. But hey, if you're someone who likes to have your hands on all the levers, you can always go the manual route with the AWS CLI and a tool like Sbuild.
And just to show you how slick this can be, look at this workflow for SAM. It's literally 3 commands. SAM init gets you started. SAM build does all the heavy lifting of compiling and packaging, and SAM deploy sends it on its way to the cloud. It's that easy. The framework just handles all the complexity for you.
Awesome. Our function is live in the cloud. We did it. But our job isn't over, not by a long shot. Now we need to keep an eye on it and understand what it's actually doing. So, by default, anything and everything your function spits out, especially anything you use console.log for, gets sent straight to Amazon CloudWatch logs. Think of it as your function's diary. Every function gets its own log group, and it's always the first place you should look when you're trying to figure out what's going on. But if you want to go from just basic logging to pro-level observability, you have got to know about Power Tools for AWS Lambda. It's a toolkit provided by AWS that makes it incredibly easy to do things the right way. Its logger, for example, automatically creates structured JSON logs and throws in super useful context, like whether it was a cold start or not. It's absolutely invaluable. And for when you need the 30,000-foot view, Lambda also plugs right into AWS X-Ray.
This lets you trace a request all the way through your system, from your function to other AWS services it talks to. And yep, you guessed it, PowerTools makes enabling this a total breeze too.
All right, let's wrap this up with some golden rules. These are the key best practices that'll take your functions from just working to being truly professional grade. This slide is pure gold. Seriously. First, keep your main business logic separate from the Lambda handler itself. It makes unit testing so much easier. Next, reuse those connections. I know we said it before, but it's that important. Always initialize clients outside the handler. Third, never, ever hard-code things like bucket names. Use environment variables. Always. Also, keep your packet size lean. The smaller it is, the faster it can start up. And finally, write idempotent code. That's just a fancy way of saying your function should be able to handle the same event twice without breaking anything, like it won't accidentally charge a customer's credit card 2 times.
So what's the big takeaway here? It's that even though there are a few hoops to jump through, the amazing tools we have today, like SAM, the CDK, and libraries like PowerTools, make running TypeScript on AWS Lambda easier and more powerful than it has ever been. It's totally accessible.
So there you have it, the complete roadmap, from code on your machine to a live monitored function in the cloud. You have everything you need to get started. So the only question left is, what amazing, type-safe, infinitely scalable application are you going to build first?